Hello and welcome. In this video, we're going to be talking about rational exponents. Of course, we know that an exponent basically just means that you're multiplying the same thing over and over and over again, and the exponent just tells you how many times you need to multiply it. So if I had 2 to the power of 3, right, that's 2 times 2 times 2, which gives us 8. So, of course, we know that when we're talking about rational numbers, we're usually referring to whole numbers and, more importantly, fractions. So basically what we're going to look at today is the meaning of a fraction exponent. So a 1/2 power or a 1/3 power or a 1/4 power. So the basic idea is that a rational exponent, or an exponent that's being expressed as a fraction, functions the same way as a root. So a 1/2 power is the same thing as a square root. A 1/3 power is the same thing as a cube root, so on and so forth. So the first thing that we're going to look at in our examples is basically how to switch back and forth between those different forms. So if I'm looking at number 1 here, and I want to take the square root of 8 and just write it with an exponent, the 8 is going to stay the same, and the exponent is going to be the fraction 1/2. And that's really all there is to it. The next one, number 2, where it says cube root of 5 to the power of 8, it looks more complicated, but it's really not. So let's focus in on that for a second. The thing to remember about your rational exponents is that the root is always the denominator of the fraction. So when I rewrite my expression, whatever the root was goes on the bottom. And if I had any exponents, then those remain in the numerator or on the top. So again, if I want to take the cube root of 5 to the 8th power, and I want to simplify that down into a rational exponent, the 3 simply goes on the bottom, so the exponent is 8/3. Number 3 is going to work basically the same way. So whatever the root is, that goes on the bottom of my fraction. If I see an exponent, that's going to go on top. So I know that I'm going to need a 3/4 power, and then the 3x is just going to stay the same. So the 3x to the 3/4 power is the same as the 4th root of 3x cubed. Notice that the extra parentheses with the cube on the outside didn't really change the way that our exponent looks. So don't let that throw you off. Those extra parentheses are often there for formatting, because the root itself kind of tells us which things are grouped. So whatever's under that square root is what goes in your final parentheses. So since the 3 and the x are both under the root, I need a 3x as my base, and then the 4 and the 3 are what form the fraction of our final exponent. For our next few examples, we're basically going to do the same thing, but go the other way. So we have 3 different expressions. We want to write them using radical notation. So that basically means we're going to write them using those root symbols. So just like in the ones before this, the root represented the denominator of the fraction. So if my expression is given with a rational exponent, then the denominator of the fraction is the root. So if I see 4 to the 1/5 power, that means the 5 is my root, and the 4 just goes inside. Since the numerator was a 1, I can put the 1 there if I want, but of course 4 to the power of 1 is just 4, so that 1 is an extra and I don't really need it. For problem number 5, it's going to be the same thing. So like I said, the denominator of your fraction is your root. So I'm going to need a third root, and then everything else I will just copy down. So it will be 16 to the power of 5. And then once again on number 6, the 4 is the denominator, so that's my root. So I should see a fourth root of 5xy squared to the power of 3. All right, so for these next ones, we're going to evaluate them without using a calculator. So basically, what that means is we're just going to simplify them down as much as possible. So once again, the bottom of each fraction represents your root, which means the top of your fraction remains as an exponent. So when we are evaluating, we can decide which one we want to do first, whether we want to do the root or the power. I will do the root first because I find it easier to work with the smaller numbers. But if you would rather do the exponent first, that's also okay. So what I'm going to do is first rewrite it in exponent form. So if I have a denominator of 2, that means I need a square root of 4 with an exponent of 3. Of course, I know the square root of 4 gives me a 2. And I know 2 to the third power is 8 because I just did 2 times 2 times 2. Now for question number 8, we see that the exponent ends up as a negative. So basically what that means is we're going to take the reciprocal of whatever the answer would normally be. And so of course reciprocal just means that it goes on the bottom of the fraction, or if you have a fraction, that the fraction flips. So when I see a negative exponent, I know I need 1 over something. Since I see a 2 on the bottom of my fraction, I know I need a square root. And then we copy down the base. And once again, we said if the exponent is a 1, then we can leave it off. So to simplify this, I'll take the square root of 9 to get 3. So once again, for question number 9, the denominator is a 3, so I know I need a cubed root. And then the top of the fraction is a 2, so I need an exponent of 2. When I do the cubed root of 8, I get 2. And then 2 squared gives me 4. Finally, for number 10, I see a negative exponent, so that means I'm going to need a fraction. I see a 5 on the bottom of my exponent, so I need a fifth root. And then since the numerator of the fraction was a 3, that's going to remain as my exponent. If I take the fifth root of 32, that gives me 2. And 2 to the power of 3 is 8. So my simplified fraction is 1/8. All right, for these last two examples, there's basically 2 rules that we need to remember from way back in Algebra 1. So for number 11, the rule we're going to use is that if I multiply two numbers with the same base, so let's say I'm taking x squared times x cubed, my answer is the two exponents added together. So for number 11, since the 5 matches, I can combine them by adding the 3/4 and the 1/4. So of course, 3/4 plus 1/4 is 4/4. And of course, we know 4 divided by 4 reduces to 1. So the simplest version of this is literally just 5. For number 12, we want to remember that when I see two exponents on the same number, the exponents get multiplied together. So if I had x squared raised to the power of 3, the total exponent would be 6. So for number 12, I'm just going to take this 6 and distribute it to my two powers. So my a would have 6 over 2 as its exponent, and my b would have 12 over 3 as its exponent. And then when I go in to simplify, 6 divided by 2 reduces to 3, and 12 divided by 3 reduces to 4. So the simplest version of number 12 is a cubed times b to the 4th. That's all I have for this one. I will see you guys next time.